Welcome you all. In this session, we are going to discuss in detail about the functional building blocks in 8051 microcontroller. Expected outcome: after successful completion of this session, the student could able to explain the functional building blocks in 8051 microcontroller. Microcontroller, a single chip computer or a CPU with all peripherals like RAM, ROM, I/O ports, timers, analog to digital converters, etc. on a single chip. So that's the major difference between a microprocessor and a controller. In processors, we need to add or we need to connect or interface the peripheral devices. Here, a part of memory and some peripheral devices will be within a single chip. That's the major difference between a controller and a processor. So, some examples for microcontroller are Motorola 6811, Intel 8051, Zilog Z8 and PIC 16X are some few examples for microcontroller. So this is the basic building block for 8051 microcontroller. So within a single chip you can see ALU, timer and counter, stack pointer, accumulator, registers, internal RAM, I/O ports, internal ROM, interrupt circuit, clock circuit and program counter. So all are within a chip, part of memory. If you can go for extendable memory, but even though it has some memory, in addition to this some few features are inbuilt within a single chip. So that is a major difference between a controller and the processor. And let us see the silent features of 8051 microcontroller. It has 4 KB on chip program memory, 128 bytes of chip data memory, 8-bit data bus, 16-bit address bus, 32 general purpose registers each of 8 bits, two 16-bit timers T0 and T1, 5 interrupt signals, 3 among 5, 3 of them are internal and 2 external. 4 parallel ports are there: port 0, port 1, port 2 and port 3, with on total of 32 I/O lines. This is the architectural diagram for 8051 microcontroller. So here you can see the ALU block at the very first, arithmetic and logic unit, followed by A and B register, followed by program counter and data pointer DPTR, DPH and DPL. Next we have the status word or flag, it's a 8-bit, followed by special function register RAM and 4 kilobytes of ROM. In addition to this, in special features I have quoted, it has 4 ports: port 0, port 1, port 2 and port 3. So the program status word, it is a bit addressable, and here each bit represent a flag. So I have represented the bit diagram of the flag register or the status register. So CY represents the carry flag, AC represents the auxiliary carry flag, F4 represents the 0 available in general purpose, RS1 and RS0. These two bits are used to select that particular register banks. So we have a set of register banks. So in the forthcoming slide, you will be getting more idea with respect to RS0 and RS1. So you will be forming a truth table. With the help of that truth table, you can choose the particular register bank in operation. OV represents the overflow flag, and the dash represents it's an undefined flag, so we are not using it that bit, and P represents the parity flag. So these are the flags available in 8051 microcontroller, and their bit diagram has been represented in this slide. So here comes the register bank selection. So as I told already, we have 4 register banks: bank 0, 1, 2 and 3. If suppose so the bit bank can be chosen based on RS0 and RS1 value. If RS1 and RS0 both are 0, the registered bank 0 will be selected. The corresponding address will be 00H2007. So if suppose the second case is RS1 is 0 and RS0 is 1. So if suppose this is the case, then the registered bank 1 will be selected, and here the corresponding address will be 08H to 0FH. Then if suppose RS1 is 1 and RS0 is 0, then the registered bank 2 will be selected and the corresponding address will be 10H to 17H. If suppose RS1 and RS0 both are 1, then the bank 3 will be selected. So there are 4 banks, bank 0, 1, 2 and 3. So here for bank 3 the corresponding address is 18H to 1FH. Thank you.